All right, hello everybody. This is my newest video. Let's get that out of there. This is my newest video for second semester, and I wanted to start on the Moodle page. You're going to find the presentation on Moodle if you would like it to be, or you're obviously going to see it on this video. And this video is about energy, and it kind of goes over some of the things we've talked about, and then a few new things. You're going to find it when you click on it. It kind of looks like this. It's a PowerPoint, and I'm going to kind of go back up and start from the top. And I'll remind you some quick things. First of all, I think you know this, that there are different kinds of energies. So what I'd like you to do to show me that you watched this video while you're taking notes is I'd like you to list as many different types of energies as you can and whether they're potential or kinetic energy. Again, energy is defined as the ability to do work, to do something. So I want you to first give me all the kinds that you can remember and then classify them as either potential or kinetic energy. And when you're done with that, you pause the video, but then when you're done with that, then you can replay the video. But don't just let this go. Take a second and try to list those and brainstorm. Okay, if you didn't pause it, you're getting this right away. If you did pause the video, check your answers and see. There's obviously, the answers are going to vary. I listed the ones that I could remember off the top of my head. Mechanical, chemical, electromagnetic, thermal, nuclear. There's light energy, there's sound energy. The list could go on. We did that activity together, so I'm hoping that you'll look at those. Whether or not they're potential or kinetic energy is something we're going to talk about in the next few slides. So what is potential energy? You kind of know this. It's not moving energy, but it's the potential to move. And gravity has a huge impact on this, and it's also impacted by mass and height. And as you saw with the activities that we've been doing the last few days, potential energy is very dependent on how heavy something is and how high you're dropping it from or letting it go from. Whereas kinetic energy is moving energy, and it doesn't have anything to do with the height. It's really just related to how heavy the object is and the speed that it's going, because it's moving. And you know from Newton's laws that mass is a very big determiner of speed. How is it related to work? Well, just picture a wrecking ball, and this ball is about to be swung. And right now it has lots of potential energy right here. When it lets go and the guy lets it go, it starts swinging in kinetic energy into the building and knocks the building down. We would call that doing work, getting something accomplished. And so the ability to do work is what we call energy, mechanical energy. This is a lot of potential energy right here in this guy's, in the weight here, because he's holding it above his head, but it's not moving. So lots of potential energy. If he drops that, mass and height will be dependent, but it will hurt him. Here, same thing. Potential energy, you're pulling back an elastic bow for a bow and arrow, and however big and long, how much you pull back and the mass of it will determine how much potential energy it will have when you let go, and then it turns into kinetic energy. And so it says once the bow is released, what kind of energy is found? Kinetic. When we define these terms, potential energy, because it has to do with the mass, the height, and because of gravity is involved, you multiply those three things together. So if you know all of them, you can multiply them together, and the unit you get is joules. So potential energy is m times gravity times h. Kinetic energy, again, has nothing to do with gravity. It has to do with the mass and the speed, and the way that we would define kinetic energy is 1/2 mass times velocity squared. So you would put the mass here, you'd square the velocity here, you'd multiply this time, the velocity squared times the mass times 1/2. And again, the units are joules. That's a big unit for energy. And then these are lots of examples I've talked about. I'm going to try to do these quick, but all of these are examples. Water slides, pendulums like in a clock, rainforest zip lines if you've ever done that, bungee cords, ski mountains, roller coasters. All of them are examples of where you start out with potential energy and then it turns into kinetic. Obviously, the higher up you are and the heavier things are, the faster you're going to go down the roller coaster. Can you think of any other real-world examples? I know that a lot of times I ask you to watch the videos, and the way that I'm going to ask that you watch this one is by having answers to these questions. So I am going to ask for these. If you didn't do the other ones from before, like up here, maybe try to do those too, because I'm looking to see if you really are taking notes and kind of paying attention to what I'm asking you to write. So first, please write down any other real-world examples. I gave you one, bungee cords. When you drop from the bridge, you have a lot of potential energy, turns into kinetic energy, stretches and kind of turns into potential energy, which flips you back up into kinetic, and you keep going. And of course, what's really interesting is that energy can't be created or destroyed. It can only be turned into other forms of energy. We always conserve energy. So you cannot make energy. Therefore, when you're dropping something like this roller coaster, you will never be able to get to a higher hill when you've started up here. So to see how this says H1, this H2 and this one here even, those are never going to be able to be as high as this one, because this is going to go and turn into kinetic energy, and you can end up having more energy at the end than you had at the beginning. But because we lose a lot of energy with sound and heat, there's going to be some energy lost to sound and heat and turned into those. So energy is still conserved, but it's turned into other forms of energy. When the roller coaster gets up to about here, it's obviously going to need to stop, and then it's going to go down, and then it won't go up nearly as high as even that one. So each hill is a little bit lower than the next, because energy cannot be made. So you can never gain more energy than you've started with. So this guy on the skateboard, he can't go up to here, and then when he gets to the other side, he's not going to be able to go up even higher and higher. At some point, he's going to be losing some of that energy. You cannot, with the same amount of force, get the same height. Now, if he puts more force into it or does a certain move, he might be able to get it higher, but then he's adding more energy to it to get it to do that. When you then want to kind of figure out, all right, I've got all this potential energy, I'm going to let go of something and it's going to turn into kinetic energy, the way you would then write that is, since potential energy is m times gravity times height, h, you can set that equal to the kinetic, because the potential is going to turn into kinetic. So when you set these up equal to each other, you can actually figure out some really neat things like velocity. Velocity, you would take this, you would leave it as v squared, times this by 2 on both sides to get rid of the half, divide by m on both sides, you'll get rid of the m, and you'll basically find out that the velocity is equal to the square root of 2 times g times h, because the m got canceled. Now I'm going to show you this. I know that's a lot to tell you, so I'm going to show you this in class 2. If you have any questions on this, you should be writing this down so that when I say, are there any questions on the presentation, you can ask me about this. And go back and listen to it too. So take a look. This says, I want you to answer these questions and have them ready for me. First one, name 2 forces that affect the motion of this car. Then, describe to me how the potential and the kinetic energy will change as the car rolls downhill. And then the last thing I want you to answer is if the roller coaster will ever be able to get to point X on this track, given what you see here. Yes or no, and why. So take a few, again, this might take you a few minutes. This is your assignment. Answer these to the best that you can. If you have questions, then when I say are there questions on the video, that's a place for us to start. And then I want you to think about the bucket activity where you swung a pendulum and you swung the bucket. And it's basically kind of trying to get you to look at the velocity and the potential energy and kinetic energy of a certain ball that has a certain height and has a certain mass. And I'll show you how to do that in class. But again, you have to go back to using these formulas and you plug the numbers in. I'll give you an example in class. And last but not least, we've done a lot of work with Hot Wheels ramps, and I want you to kind of think about if you knew the mass and the gravity and the height and all that stuff, you could calculate the potential energy and kinetic energy of a toy car. And finally, I want you to answer this question. Do you think this would hurt? I want you to click on this link here when you go, and it's a video that shows a bowling ball being swung back and forth, and I want you to answer this question. Will this demonstration hurt that person? Why or why not? So you'll have to click on here to watch that. So that's a lot I'm saying to you. I hope you understand where I'm coming from, and we will talk in class if there's some things you don't get. Have a good night, and let's talk tomorrow. Please make notes of where you want to go over some things. Thanks.